Hi students, we're looking at notes section 2.1 functions, function notation, and non-functions. So we want to start by looking at our vocabulary, and we want to just think about what these different words mean. And so our function notation, that's just a way of naming functions. And so we'll typically call them f of x, which is just meaning the function f, where x is the variable. And we'll plug in numbers for x, and we'll get out y. F of x is equal to y. X is equal to x. That's super important. And we might also have g of x or h of x or other numbers. A function is a specific type of relation, and relations are just a set of ordered pairs. And a function is the relation where each x value has exactly one y value. And let's take a look at some functions versus non-functions to clarify that idea a little bit better. So on the right-hand side are non-functions, and on the left-hand side are functions. So we usually use the vertical line test to test if something is a function. The vertical line test. So a vertical line goes straight up and down, and the formula is x equals a number. So with a vertical line test, we're testing the x values to make sure that there's just one x value and one y value. So my vertical line, it touches my function just one time on a function. Any vertical line just touches my vertical line once. No matter where I draw it, it will pass through my vertical line at just one place for a function. So it passes vertical line one time for functions. What about for non-functions? Well, I can take my vertical line, and here it passes it 1, 2, 3 times. So non-functions fail the VLT, vertical line test, because they pass 2 times or more. For example, 3 in this case. Here, it touches my vertical line 2 times. Now, is that the perfect vertical line? No, it's a little slanted, but you can tell. It would touch my vertical line twice, meaning there are 2 y values for one x value. And that means it's not a function. How else can we tell? Well, by looking at our table of values, what we're looking for are unique or different x's. Another way of saying that is no repeats. If there are no repeats, it's a function. Looking here, I have x repeated 1, 2 times. So this is a fail. I have one x value that gives me 2 different y values. And so perhaps there was an error in calculations if you were plugging it into an equation, or it's just plain old a non-function. And so we're looking for one x value to have one y value. You can have 2 different x values, and they can all have the same y value, as we notice here. These are all the same y values, and that's totally allowed. But we cannot have the x values repeat. Well, that's very helpful. What does that mean for function notation? Almost nothing about function notation. It just makes it easier for us to evaluate functions. So here we can see the benefit of function notation. And that's because I've got 3 different functions, and they have different names. So I've got f, g, and h. H is a picture. Pictures are functions. I could tell this one would pass the vertical line test, because if I drag my vertical line across it, it doesn't touch my vertical line twice at any spot. So on all of these, we are doing some function evaluation. So this one says f of 4. That means that I have the x value equals 4 and the y value equals unknown. because remember, all of these functions mean y equals negative 4x minus 9.3. This one means y equals 0.5, come on, x, well, it's kind of glitching. It means 0.5x plus 40, and then the last one means y equals this graph. And so I'm going to replace the x in the expression part. I don't need to replace it on the y part. So I just say negative 4 parentheses x minus 9.3. That's the equation. And now I'm going to replace the x with the number we're told, which in this case is 4. So now I just do my calculations. Negative 4 times 4 is negative 16, minus 9.3 is negative 25.3. And that is f of 4 equals negative 25.3, and that represents an ordered pair. The ordered pair where x is 4 and y is negative 25.3. Interesting. What if I did f of 0? Okay, so that means that I have the x value equals 0 and the y value equals question mark, right? It's 0 comma something, and we're figuring out what y is equal to. Oh, okay. So I start with my expression that f of x is equal to, it's negative 4 parentheses x minus 9.3, and this time it's f of 0 instead of f of x. So that means I replace the x with 0. And negative 4 times 0 is 0. 0 minus 9.3 is negative 9.3. So this represents, this is the answer. Negative 9.3 is the answer. But it represents the ordered pair as 0 comma negative 9.3. Negative 9.3 is the y value. Let's do one more, f of x. So here's f of x equals 0.8, which means the 0.8 comma something. Well, let's find out what it is. Negative 4 minus 9.3, and instead of x, I'm plugging in 0.8. So 4 times 8 is 32. It's going to be negative, and it's going to have one decimal place. Then minus 9.3, those are both negative, so I add and keep the sign the same, and I get negative 12.5 as my answer. And what does that mean? Well, that's the y value that I get out when I plug in 0.8. And so it really represents the ordered pair, 0.8 comma negative 12.5. Well, let's try these h of x's then and see, and g of x's, how they work out. So when I plug in g of 12, I'm plugging in, let's do this nice color. I'm plugging in to 0.5x plus 40. And I have the information 12 comma something. So I'm plugging in the 12 for x, and then I do 0.5 times 12, or half of 12. Half of 12 is 6. 6 plus 40, I get 46. So the answer for g of 12 is 46, and it represents the ordered pair 12 comma 46. Cool, let's try g of 10. Sorry, g of negative 10. So it's 0.5 times negative 10 plus 40. Half of negative 10 is negative 5 plus 40. I get 35. Which really means the ordered pair, what? Negative 10 comma 35. Cool. What about g of 0? Oh, g of 0 means I plug in 0 for x to g. So that's 0.5 parentheses plus 40. I've got 0 comma something. I'm going to find the y-intercept. Okay, so 0 for x, that's right here. That makes 0 plus 40. I get 40 as my final answer. What about g of negative 15? Okay, same idea. I'm plugging in negative 15 for x. So I've got 0.5 times negative 15 plus 40. That's half of 15, 7.5, and it's negative. So I get the answer 32.5. That represents the ordered pair, negative 15 for x and 32.5 for y. Very cool. Our last one is looking at the picture, and it's the picture h. So here I have h of negative 3, so that's negative 3 comma something in terms of what it means. So that's the x is negative 3. So here's negative 3 for x, and then here's where the function is. So I know that it's negative 3, and the y value there is 0. So the answer is 0, and it represents negative 3 comma 0. Well, what about h of 0? Is h of 0 negative 3? No. H of 0 says we've got 0 comma something, and we're looking for the y value. So I go to 0 for x, and I go to the function. The function's right here. Very, very nice. That tells me that my answer for y is 90. So h of 0 equals 90. Because they're just asking us for the y value. I'm just reminding you that it means the ordered pair. But we can just say the answer is the y value. So what about for h of 2? Well, we find 2 on the x-axis. We find the function, it's all the way up here, and we get the answer is 150. Now look at this star problem. Find x if h of x equals 150. This one is backwards. Okay, so what is this one saying? H of x is equal to 150. And that means that we haven't replaced the x yet. And so this is a very interesting question. So what's the x value that gives me the y value of 150? X equals 2. We just did that problem, right? Let's do a few more like that where we go backwards, okay? So where we say find x if h of x or g of x or f of x equals a number. So let me erase these things and we'll do a couple like that. So we'll go backwards and we'll say, okay, here's f of x and here's g of x. Find x if f of x equals 3. So that is x comma 3, which means we have the y value. So in f, I'm going to say 3 equals negative 4x minus 9.3. And now I'm going to go backwards and solve for x. So I add 9.3, and I get 12.3 equals negative 4x. Dividing by negative 4, I get x equals, let's check that with my calculator, 12.3 divided by 4. I know my answer is going to be negative, and I get negative 3.075. So now I've found an x value because it said f of x equals 3. So you can tell the difference because the letter x is still there. We're going to do some more practice problems with these, so that'll be it. Thanks, you guys.